Hello everyone. In this video, first understand the problem. Our task has three parts. First one is take n integer elements. Second, sort them using the merge sort. Third, measure how much time the sorting takes for different values of n. For example, we can run the program with n is equal to 6000, n is equal to 8000, n is equal to 20,000. All these values satisfied n is greater than 5000. What is merge sort? Merge sort is divide and conquer algorithm. The idea is very simple. First we have the array that we have to divide, right side and left side, again divide, after that sort, after that merge, after last we will get sorted array. So remember, divide, sort, merge. Let's take a small example. Suppose our array has the values 8, 3, 6, 2, 7, 1, 5, 4. Step 1, we have to divide. Divide into 2 halves. Again divide into 4 halves. Again. Now each part contains one element. A single element is already sorted. Now start merging. 8 plus 3, it becomes 3, 8. 3 plus 2 becomes 2, 6. Now our array is 3, 8, 2, 6, 1, 7, 4, 5. Merge again. Next 2, 3, 6, 8 and 1, 4, 5, 7. Finally, so the final answer we will get merged array and it is in sorted order. Now understand our Python program. Import random, import time. We need random numbers for our experiment, so we are using the random. Time, we need to calculate how long merge sort takes. Here is the merge function, def merge left comma right. Students, this function is responsible for combining two sorted lists. Suppose left and right. We compare this first element 2 and 1. Since 1 is less than 2, we take 1. Then 2 and 5, take 2. Then 6 and 5, take 5. Finally, we get 1, 2, 5, 6, 8, 10. Initially, result is equal to empty. After comparisons, result is equal to 1. Then 1, 2. After that 1 to 5. And finally 1 to 5, 6, 8, 10. I is equal to j is equal to 0. We use two variables to keep track of positions. I is equal to position in the left list, j position in the right list. For example, left 2, 6, 8, it position pointing to 2. I is in 2 position. Right 1, 5, 8, j position. Compare the element. While I is less than length and j is less than the length of right. This means continue comparison while both lists still containing the elements. Then if left I less than right of j, we compare the current elements. If the element is smaller, then append. We put it into result. Otherwise, we take elements from the right list. I repeat, move to the next element. I plus is equal to 1 means I is equal to I plus 1, j is equal to j plus 1. So we move forward through this list. Remaining elements after comparison loop, result is equal to left of I, result is equal to right of j. Sometimes one list still has elements remaining. For example, left side 6, 10, right side 8. If 8 is selected first, we may have 1, 2, 5, 8. The remaining elements 6, 10 are then added. Next, our second function is our merge sort function. Now comes the main part, merge sort. This function performs the merge sort. If length of array less than is equal to 1, this is called the base condition. If the array has 0 elements or 1 element, there is nothing to sort. For example, 7 is already sorted. Find the middle. Mid is equal to length divided by 2. Suppose array has the 8362. Length is equal to 4. Mid is equal to 4 divided by 2. Therefore, 2 is the mid. So, left 8 3, right 6 2. Recursively sort left and right. Left is equal to merge sort array of mid. This takes left half and sorts it. And right is equal to statement takes the right half and sort it. Finally, returns the merge left right, combines two sorted halves. Recursively sort left and right. Left is equal to merge sort of array. This takes the left half and sorts it. Right is equal to merge sort of array. This takes the right half and sorts it. Finally, returns the merge left, right, means combines the two sorted halves. Now our actual experiment. The program asks enter the number of elements more than the 5000. Suppose we entered 10,000. Therefore, n is equal to 10,000. The program creates 10,000 random integers. Before sorting, the program displays some numbers. Students, these numbers are random and unsorted. The program displays only the first 10 numbers because displaying all 10,000 numbers would make the output huge. Start measuring time. The computer records the starting time. Then the actual sorting takes place. After sorting, records the ending time. The program calculates execution time. That is, execution time is equal to end time minus start time. And it displays the output. The questions specially say run the program for varied values of n greater than 5000. So we should test several values. For example, 6000, 8000 and check the time taken for execution. These times are sample values for explaining the experiment. Your actual computer will produce different times.